So this video is about finding and doing problems with the knowledge of the central limit theorem that we talked about last class or last video. So the this problem talks about the phone bill. So it says the phone bills for residents of a city have a mean of $64 and a standard deviation of $9. Random samples of 36 phone bills are drawn from this population. The mean of each sample is determined. Find the mean and standard error of the mean of the sampling distribution. So we want to find, what we're actually asked to find is the mean and the standard error of the mean of the sampling distribution. So that's mu sub x bar basically and sigma sub x bar. Well, if you remember from the last video, mu sub x bar is equal to mu and sigma sub x bar is equal to sigma over the square root of n. Well, the mean of my population is $64, so the mean of my sampling distribution is $64. So that's it. Pretty easy, huh? The standard deviation is $9, and we divide by the square root of n. N is my sample size, which is 36. So this is going to be $1.5 when I do that calculation. And that's it. That's all you have to do. All right, so try the next one on your own and see if you get the same solution as me, and you may want to pause the video. All right, so the next one is the heights of fully grown white oak trees are normally distributed with a mean of 90 feet and a standard deviation of 3.5 feet. Random samples of size 4 are drawn from this population and the mean of each sample is determined. Find the mean and standard error of the mean of the sampling distribution. So this is mu sub x bar, which again is equal to mu, and they tell us the mean is 90. I put dollars again, I meant feet. So the mean is 90 feet. And the standard deviation, which is sigma sub x bar, is sigma over the square root of n, which is 3.5 divided by the square root of 4, which is 1.75 feet. Okay, and that's it. Now the next one is a little bit more in depth. So it's very important you recognize that what these we're talking about is the sampling distribution of sample means. And that's exactly what we're going to be talking about in this next one. But now we're going to actually find a probability using this information. So the mean room and board expenses per year of four-year colleges is $6,803. You randomly select 9 four-year colleges. What is the probability that the mean room and board is less than $7,088? Assume that the room and board expenses are normally distributed with a standard deviation of $1,125. So first of all, I want you to note that this is not about an individual room and board cost. This is about the mean room and board cost. The question is, what is the probability that the mean room and board cost is less than $7,088? If I just asked for the probability of one room and board cost, you could do that before you watch this video, because that's what we did in section 5.2, section 2 of chapter 5. But now we're talking about the mean. So now things are a little bit different. Now, to do this problem, what we can do is we want to find the probability that not x, but x bar is less than $7,088. And if we know that the room and board expenses are approximately normally distributed, which we're assuming, the problem says we can assume that, we can use z-scores. Well, remember, z-score is x minus mu over sigma, but we don't have x, we have x bar. So what we need to do is we need to change it to x bar minus mu sub x bar over sigma sub x bar. So now our new z-score is going to be x bar, which is the mean, or which is the score that we're trying to find, 7,088. So we're trying to find the probability that the sample mean is less than that, minus mu sub x bar, which is the mean of the sample means. So that's 6,803, because that is equal to the population mean. Mu sub x bar is equal to the population mean, so that's okay. Divided by sigma sub x bar. Well, we know the standard deviation is 1,125. That's in the last sentence. But remember, sigma sub x bar is sigma over the square root of n, and n is 9. We have a sample size of 9. Because just like up here when we talked about, the feet of white oak trees, we had to divide by that square root of n. So this square root of 4 or in this case, the square root of 9 ends up being in the denominator. So we have this fraction down here. So we can put this in our calculator and calculate that, and we end up with a z-score of 0.76. So our probability that z is less than 0.76, we can go to our normal distribution table and look it up. So we want to find the z-score of 0.76 is 0.7764. It's right here. And it's a less than, so we don't need to do anything. So that's the answer. 0.7764 is the probability. Okay. And we're going to write it in a complete sentence. So what this is 77.64% of the means of 9 4-year college room and board expenses are less than $7,088. So 77.64% of means of 9 4-year college room and board expenses are less than $7,088. And notice there's a few things I have in here that you must include. First of all, I have the percentage, which is a given. Okay. But second of all, I make it clear, I'm talking about the mean of 9. If you don't have the mean of 9 4-year colleges, it's wrong, because first of all, you're talking about the sample mean. And second of all, if I have a different number of 4-year colleges, my z-score would be different, because it's based on this. The z-score is based on how many 4-year colleges I have. You know, if I took the mean of 10 4-year colleges, that's going to have a different standard deviation. The probability is going to change. So make sure you're doing the correct thing when you, or you're writing the correct sentence when you do this. And then, of course, I end with context in the sentence. So let's summarize this problem a little bit. First of all, I noticed they're talking about the mean, not an individual room and board expense. Second of all, because they're talking about the mean, I use this z-score formula, x bar minus mu sub x bar over sigma sub x bar. And I remember for the sigma sub x bar, which is the most important part, and really the only difference in this problem than what you did before, is dividing by that square root of n. And then after I find the z-score, I still look it up in my table, and then I write my sentence. Okay? So let's do this one more time, but with credit card balances. So I want you to think about this problem and think about how you would do part 1 and actually part 2. Think about both of these and make sure you read the question carefully based on the information that they give you. And try it on your own, pause the video, and then watch my solution for the problem. So hopefully you paused the video and did the problem on your own. So this first question, they give us the mean, which is 2,870. They give us the standard deviation, which is 900. Now the question here is, what is the probability that a randomly selected credit card holder has a credit card balance less than $2,500? Well, it's a randomly selected credit card holder. It's not the mean of several. So if I want to find the probability that x is less than $2,500, this is a section 5.2 problem. Back to section 2. All you have to do is just use the z-score formula that you love so much. 2,500 minus 2,870 over 900, 0.76. And we look up that 0.76, or not 0.76, I'm sorry, that is my bad. It's like, that doesn't make sense. I was looking at the previous problem. It's negative. Duh, it should be negative because I'm subtracting a smaller minus a larger number. Negative 0.41, I think is better. Okay. So negative 0.41 is 0.3409. And so we can say 34.09% of credit card holders have a balance less than $2,500. Okay. All right, now let's read the next question. The next question is, I'm randomly selecting 25 credit card holders. So right away, I have a sample. And now the question is, what is the probability that the mean credit card balance, so the probability now that X bar, not X, but X bar is less than $2,500. So now my z-score formula is X bar minus mu sub X bar over sigma sub X bar. But much of the numbers are the same. The mean that I'm talking about is 2,500. Mu sub X bar is still going to be 2,870. Sigma is still 900, but now I have to divide that 900 by the square root of 25. And when you put that in your calculator, and by the way, depending on the calculator you have, I would advise doing this in a couple steps, maybe just doing the numerator, the denominator, and then dividing the two numbers. It just depends how you want to do it to make sure you don't mess up. But anyway, the z-score is negative 2.06, so that is what I need to look up. It's a z in my table. .0197. So 1.97% of means of 25 credit card holder balances are less than $2,500. So once again, notice the difference in the question and how it affects the probability. This probability is 34%, almost over a third. This probability is not even 2%. Notice how much smaller the probability is because now I'm getting a sample of 25 credit card holders. So, compare the probabilities in 1 and 2 and interpret the answer in terms of the auditor's claim. I'm not really concerned as much as the auditor's claim, but basically the probability, this is the takeaway I really want you to get, the probability of getting a sample mean less than, what was the balance? $2,500 is much smaller because it's a smaller standard error because of the smaller standard error. And to kind of give you an illustration of this, let me draw this the best I can here. So this is, let's say this is my credit card balances. The mean is 2,870. Okay, so then when I got I want to find the probability of balances less than 2,500. Well, that's about a third of the under the thing. But if I'm looking at the distribution of the means, my distribution is much skinnier. And now I'm looking at this area here. So this green area is about 1.97%. And this blue area is about 34.09%. And you can see that because my standard deviation is so much smaller, the area is going to be so much smaller as well for the green compared to the blue. All right, so that is the central limit theorem and the last section of chapter 5.